Morning, everybody. Welcome to lecture for today. I'll just go ahead and get started now. So just a reminder that you guys do have homework that is due this coming Sunday. So Sunday nights is always when all the assignments are due. And so this week it's 1.1 through 1.4. And so we might actually get a little bit past 1.4 for this week, but if we do, the homework's still only going to be through 1.4. So we'll go ahead and continue on where we left off yesterday. So we are on section 1.3 here, and this is where we left off with doing some graphing. So you want to write it, the following in slope-intercept form and identify the slope and the y-intercept, it says, and we're going to use the information to graph. So far, we've graphed things like this, but we've done that by finding the x and the y-intercepts. So this time, we're going to be using the slope and the y-intercept in order to graph something. So it doesn't matter if you have an f of x here or a y, it's really the same thing. So this right here, the 3/4 is going to be the m, and then this right here, -3, this is your y-intercept. Okay, so slope here, if it asks for slope, that's going to be 3/4. And then the y-intercept, we can write that as a coordinate. You have to put a 0 whenever you have the y-intercept. So it's 0, comma, and then -3. That comes directly from the equation. So this is why it's called slope-intercept form, because you can find the slope and the y-intercept directly from the equation. Now that we have this, we're going to plot this here. So 0, -3 starts right there. All right, so now with the slope, the way that you work with this is you start from the y-intercept. The top number of the slope, that's the part that you either move up or down. If it's positive, you're going to go up. If it's negative, then you're going to go down from that one. The bottom number, that's your change in x. If it's positive, you move to the right. If it's negative, you move to the left. So since both of these are positive, from the starting point here, from the y-intercept, I'm going to go up 3 units and then 4 units to the right. And then that's going to give me my next point on the graph itself. So again, I'm using the slope in order to generate all of my points. I can keep doing this over and over again. I can go up 3/4, up 3/4. I can do that forever, but you only need 2 points in order to determine a line here. So again, how we did that, we did starting from here, we go up 3 units, and then we go 4 units to the right, and then we make a dot right there. And then we're just going to draw a line connecting through that one, and that would be your completed graph right there. So you always start with the y-intercept, then we can use the slope to get to the next point that's on there, and that would be, that's all they want you to do here. They just want you to identify the slope, the y-intercept, and then draw the graph. Now, when you do these in the My Open Math, I want to point something out here with that, because I had a few questions people asked about the graphing tool. Now, when you look at the graphing tool that's drawn there in Lumen, you're going to see a couple boxes. You'll see a couple different tools. You're going to see one that looks like this, where there is a line with 2 dots like that. And then you're also going to see like a dot tool that's there as well. So when you graph this one in My Open Math, you don't want to use the dot tool. Okay, you want to use the line tool instead, because the line tool automatically has you click on the 2 points. So for instance, if I was graphing this one we just did in My Open Math, I would click the button here that has the 2 dots on the line with the 2 dots on it, the line tool, hit that, and that's in it. Then I'll just click on this point and click on that point, and that's going to lock the graph in at that point. So don't use the dot tool, because otherwise, if you do, it's going to mark it wrong, even though it looks correct. So for some of you, I've already made the correction. If for some reason you did that and it marked you wrong, go ahead and send me an email message and I'll take a look at that. but this is how the tool should work when you do my open math. Just use the line tool whenever you're using trying to draw a line like that. Okay, so now let's go on to the next one. So the next one here, this one is not solved for y. So if I want to identify the slope and the y-intercept, the first thing I would want to do here is to solve this for y. I have to get it into the correct form, and so then that way I can figure out what the slope and the y-intercept is. All right, so let's go ahead and do that. We're going to do 4x plus 6y equals negative 12 is what we're starting with, and I'm going to subtract the negative 4x from both sides, and we get 6y equals, I'm going to put the x first, negative 4x minus 12. So that's the first thing we're going to do, subtract 4x. Put the 4x first because y equals mx plus b form, slope-intercept form, it does require us to have the x first. Then I'm going to take everything and divide it by 6. So I get y is equal to the negative 4 over 6. That can be reduced there. So it's going to be negative 2/3 x minus 2. Okay, so negative 2/3 x minus 2 would be the equation that I'm going to graph here. So now I can indicate what the slope and the y-intercept are. Slope is going to be negative 2/3, and the y-intercept is going to be negative. Actually, let me write this as a coordinate. I'll write this as 0 and negative 2, just like that. Okay, so again, for graphing this, we're going to start with the y-intercept, and that's going to be at 0, negative 2. Now for this slope that we have here, I have negative 2/3. Now this is equal to negative 2 on top over 3, and it's also equal to 2 over negative 3. So actually all three of those would be the same number. So if a negative is out front, we can either put it on the top or we can put it on the bottom. Now the reason why that's important is because that's going to determine these points that we're going to have here and which direction we're going to go with our slope. Let's look at this middle version of the slope, negative 2/3. Starting from here, because the top number is negative, that's the up and down movement is the top number, that's the change in y. Because it's negative, I want to go down 2 units. But then since the bottom number is positive 3, we're going to go 3 units to the right. So I'm going to go down 2 units, 3 units to the right, and make a dot right there. So the question is, well, what if I use this other version instead? What if I put the negative on the bottom? Okay, so let's see what happens with that. Now, if I'm going to do that one, the top number is 2. So from my starting point, I would go up 2 units. And because the bottom number is negative, that means I would go 3 units to the right. So from here, I'm going to go up 2 and 3 units to the right. So as you notice there, it actually doesn't matter which of these versions that you use. You're just going to end up getting different points on the line. So when you do this in my open math, it doesn't matter which of these points that you actually click on, as long as all of them are on the same line, that's it. So then we can just connect all this with a line, and then that's going to be our final answer there. Okay, so again, with the negative slopes like that, you can put the negative on top or you can put the negative on the bottom, and that's how you can go ahead and graph something like that. So that's your final answer for that one. Okay, so next thing is we've got a couple concepts down here. We have parallel lines and perpendicular lines. Okay, so parallel lines would be lines that go like that, that have, they don't cross. And then perpendicular lines, you would have lines that come together at a right angle there. Okay, and so the difference, the two lines like this, if they're parallel, they go at the same angle, which means the slopes should be exactly the same there for parallel lines. For perpendicular lines, they have what's referred to as opposite reciprocal slopes. So let me give you an example of opposite reciprocal. For instance, here, if I've got negative 1/2, the opposite reciprocal, first of all, would be a positive, and then I would flip the fraction over like that. So for instance, negative 1/2 and 2/1 those would be considered opposite reciprocals because they have opposite sign, and then we flip the fraction over. So for instance, if I'm starting with the fraction here, positive 3/4, that means the opposite reciprocal on that would be negative 4/3. I just take the opposite sign and flip the fraction over, and that's going to be considered slopes for perpendicular lines. Another way to tell if you have perpendicular lines is if you multiply the slopes together and you get -1, that also tells you you have perpendicular lines. So if I multiply these, I get -2/2, which is -1. If I multiply these, I get -12/12. That's also equal to -1 as well. So that's another way you can determine that one. So we're going to use all this idea on these next couple of problems here. So for this, we have a couple. So this one here, it says find the slope of a line that is perpendicular to -4/x. Okay, so I need to find the slope of a line that would be perpendicular to this one. So if it's perpendicular to this one, that means it has to have the opposite reciprocal slope of the one that's given. So for this, the given slope was, I'm going to write this as -4/1. So what I want to find is I want to find the perpendicular slope, and this is the answer to the question that I have right here. So we're going to find the slope of a line that would be perpendicular to this one. Well, if the original slope was -4, all we have to do is find the opposite reciprocal slope to what this one is. So you will flip the fraction over and make it positive, which means that 1/4 would be my answer on this. So any whole number like this, you can always write over 1 like that. Reciprocal of it would be 1/4. We're taking the opposite sign. And so that's all you would have to do on that problem. Just asking for the slope of a line that's perpendicular to this is just going to be 1/4. That would be it for that one. It says determine whether the following lines are parallel, perpendicular, or neither. So that's one of the types of problems you'll have with the homework. So, and if we need to figure out what the slopes of each of these are, and then we'll compare them afterwards. Okay, so let's start with this one, 3x minus 4y equals 12. We'll start with that. I'm going to subtract 3x from both sides, and I get -4y equals -3x plus 12, like that. I want to solve for y, so I'm going to divide everything by -4. And if I do that, I get positive y equals positive 3/4 x, because I have negative over negative. And then I have -3. So that would be the slope, or the slope-intercept form of the first equation. Now I want to do that again with the bottom one. So I have 8y minus 6x equals 16. I'm going to add 6x to both sides, so 6x plus 16 there. Divide both sides by 8, y by itself. I get y is equal to, so 6/8 is 3/4, and I have plus 2. Okay, so I have this 3/4 x minus 3, and I have 3/4 x plus 2. So what I want to do now that I've figured out, put both of these in slope-intercept form, now I can easily determine what the slope of each of those lines are going to be. If we look at both of these, both the slopes are 3/4. So because I have 3/4 and 3/4 here, what I'll put for my answer is parallel. Okay, so if they both have the same slope, then they're considered parallel. If they had opposite reciprocal slopes, then I would say perpendicular. And if we didn't have either one of these, so let's say we had 3/4 and let's say we had -3/4, for instance. So 3/4 and -3/4, well, that would be a neither, because it wouldn't be opposite reciprocals and it wouldn't be the same slope in that case. So I had one positive, one negative. That wouldn't be, that would have to just end up being neither. So sometimes you may not get any of these at all. Just depends on the problem that you're doing in the homework, what kind it actually is. Okay, so it's parallel on that one. All right, so these other ones now, we have kind of be combining some things that we talked about yesterday as far as the different formulas for the lines. Okay, that was actually in 1.2, we talked about some of those. So this says use the given conditions to write the equation. We want to do a point slope form and a slope intercept form. So it says we're passing through -2, -7, and we're supposed to be parallel to the line whose equation is this one right here, y equals -5x plus 4. First of all, this is going to be the x1 and y1 right there. And then the given slope here that we have, so the given slope was -5. Okay. It's got the word parallel here. So if I want to find the parallel slope, that's also going to be -5. So this is the slope that I want to use in this problem. Now the formula we want to use to get our answer is going to be the point slope formula we talked about the other day. Okay, so we're going to do y minus y1 equals m times x minus x1. We already have our x1 y1, and so now the given parallel slope that we found, this is your m, -5. So we can plug everything all in. We're going to do y minus -7. The m is -5. We do x minus -2. We have some double negatives that we want to simplify on that. So again, the reason why we're starting with the point slope form here is because we have a point and a slope. So that's the one we want to use. Plus, it's also asking us to find the point slope form. So that's again why we're using that particular formula. We have -5, and inside here I have x plus 2. So here is the first answer. This is the point slope form. That's the first one they asked for. If we want to find the slope intercept form, then all we have to do is multiply this out and solve for y, and that's going to give us the slope intercept form. Okay, so we're going to do y plus 7 is going to equal -5x minus 10. So we multiply both of those. And then we're going to subtract 7 from both sides. We get y equals -5x minus 17. And that is going to be our slope intercept form. Okay, so now we have both. We have both the things that they're asking for. So once you have point slope, then you just want to solve for y to get the slope intercept form. So now we have both the different forms that they are looking for here. That would be our answer for that. So the word parallel means that we have the same slope. So now let's take a look at one where we have we'll do a perpendicular one as well. So we have an idea how to do that. So let's do that one next. All right, so we've got next one. Want to find a line that is passing through -4, 2, and perpendicular to the line whose equation is this one here. So again, what we've got there on that is we have x1, and y1 for this. So we have the given slope was given as 1/3. But I want to find the perpendicular slope. Okay, so the perpendicular slope on this is going to be -3/1 or just -3. Notice I took the opposite sign. This was positive. Now I'm making it negative. And I flip the fraction over like that. So I have 1/3 and I have a -3/1. And so that's your slope you want to use in this problem. This is going to be the m we're going to use this time. We're still going to use the same formula we used last time, the point slope form. We have x1, y1, and m. We're just going to plug all those into this formula. So y minus 2 is equal to -3 times x minus -4. And with that. Okay, so now we have this. We're going to do a simplified step here. So -3 x plus 4. That's our first answer. That's going to be the point slope form. right there. And then we're going to continue with this in order to find the slope-intercept form. So we're going to let's make this a little bit clearer here. Negative 3x minus 12. So we distribute the negative 3 into both of those. Then we're going to add 2 to both sides. So y equals negative 3x. Negative 12 plus 2 is negative 10. And that right there is going to be the slope-intercept form. Okay, so that would be the other one that we have. So notice that this time, so that you have to pay close attention to what the instructions are asking you to do here. So sometimes it says parallel, and sometimes it says perpendicular. So depending on that, that's going to determine what slope you're going to use. In this case, again, it says perpendicular. So perpendicular means we have to have opposite reciprocal slope from the one that was originally given. Okay, so notice that the plus 7 that's here, we didn't use that. You don't need to use that because all we're concerned about, that's the original line. We just need to know the slope of the original line. So that's the only number we actually need from that original equation that was given is a 1/3, and perpendicular slope is negative 3/1. And then we just followed that what we did before by using the point slope formula, plugging things in and getting it. Okay. We're going to do another one of these. Let's do the next, another one of these perpendicular ones. Okay, so we'll do this here. All right, so passing through 5, negative 9, and again, we've got perpendicular to. Now this time, the line that was, we're given a line that's not in slope-intercept forms. They give us the original line is this one here. So in order to determine what the given slope is, we have to take this original line and solve for y first. So let's do that now. We're going to do 7y equals, we're going to move the x and the negative 12 over to the other side. So when you move them across the equal sign, they change signs. So positive x becomes negative x on that side. Negative 12 becomes positive 12 when you move it across the equal sign. Now we're going to divide everything by 7. So I get y equals, that's negative 1/7, we can write this as, and then plus 12/7, which we'll just leave that as a fraction. So now the given slope is going to be negative 1/7. That's the original slope of the equation that was given to us. We want to find a perpendicular slope, which means we have to take the opposite reciprocal of negative 1/7. Okay, so if I flip that, I'm going to get 7/1 in an opposite sign. So my perpendicular slope is going to be 7 in this case. And then I can go ahead and move on to the point slope formula like we did before. Okay, so again, what made this problem different than the ones we did before is the 2 previous problems we did, both of them already had the equation written out as y equals. So we could easily just tell what the slope was because it was in the point slope form. Unfortunately, we can't do that this time because this time it gave us a line in a different form, in the general form. So instead, we had to go ahead and go through this to solve for y in order to find what the given slope was. So that's what made this problem different from the previous 2. Okay, so here's x1, y1 is that right there. So I'm going to do y minus negative 9 is going to equal m, which is going to be 7, x minus 5. By the way, if this problem would have said the word parallel instead of perpendicular, then I would have been using negative 1/7 as my given slope. All right, so because it says perpendicular, that's why we're doing opposite reciprocal. It's only if it says parallel, then you're going to use exactly the same slope. So that's the reason why I had to do the opposite reciprocal here. All right, so now let's simplify this. Y plus 9 equals 7 times x minus 5 right here. That is the point slope, okay? And then we're going to continue this. Y plus 9 equals 7x minus 35. We're going to subtract 9 from both sides, so we get y equals 7x minus 44. And this right here is the slope-intercept form would be that one. So we got point slope given here, and we have slope-intercept is the one down below. So we have both of those answers that we have here. Another type of problem that's going to be in this section is word problems that deal with linear equations. So we have this one here. Cost of renting a truck is $20 a day plus 50 cents a mile. It says write a linear equation that relates the cost C in dollars. Arrange the truck to number of miles, number of X miles driven. What is the total cost if you drive 160 miles? All right, so a couple of things we have to do on this. We have to first come up with the equation, and then we're going to answer the question that comes afterwards once we have the equation there. Now we want to use the variables specifically that are given here. Okay, so I don't want to use a Y or something like that because it's not given there. So if you do these problems in MyOpenMath, they're going to expect you to use the exact same variables that they set up here. So because it says cost, I do want to come up with an equation that starts with C equals. Now, the way these problems work is you have a fixed cost and you have a variable cost. Okay, and you're usually going to add those together. So the total cost of renting a truck, no matter what, I got to spend the $20 per day, no matter how many miles I drive. But then I have a variable cost here of 50 cents per mile that I have. So my cost is actually going to be the variable cost plus the fixed cost. So I'm going to put variable cost plus fixed cost. Okay, so I'm adding these together. I have a variable cost and I have a fixed cost. Okay, well, I already know that the variable cost has to do with this 50 cents per mile. Now, I want to write that as in terms of dollars. And so that's going to be $0.5. I'm going to use X to indicate the number of miles that's driven. I have a plus sign from before. And I have my fixed cost, which is $20 per day. Okay, so that would be the equation that I'm going to put down. That would be the first part of the answer because it'll have a blank for you to type in the equation itself. So that's the first equation, C equals 0.5x plus 20. But then there is a second part of this question. It says, what is the total cost if you drive 160 miles? Okay, so now what we're going to do is we're going to use this formula we just came up with. And it's telling us 160. So 160 is actually the X. So that's to me the number of miles. So what I'll do here is I'm going to put in 0.5 times 160 and then plus 20 here. Okay, so 0.5 times 160 plus 20. I'm just putting 160 in for X. And now I'm just going to compute this. Half of 60 is 80. So I have 80 plus 20. Order of operations says I have to do multiplication first. That's why I did that step first before I added it. And so now the total cost is going to be $100. Okay, so that would be if I drive 160 miles, then that's the total price that I pay would be $100 on that. All right, so then I'm going to take a look at MyOpenMath here just to make sure we didn't forget anything here. I was going to make sure that we cover the correct thing and there's no extra things that will may throw you for a loop in the homework here. So I'm going to take a look at that. And let's see. Yeah, so we got so we got those cost equations. We have graphing something with finding the slope on the Y-intercept. Yep, so it looks like everything that we've covered here. We have plot points and things like that. So yeah, so it looks like we've covered everything all in here. Just want to make sure first, always do a quick check to make sure with the homework that we've covered everything. So yeah, so we do have that. Okay, so so now we're done with, this is 1.3 that we're finished with. And so the next one we'll go to is 1.4. So your homework this week does only go up through 1.4. So this section, most likely I'm going to be able to finish probably a lot of this section today, and then tomorrow we'll probably just finish up a little bit of it. But then tomorrow we'll continue and go on with 1.5. So actually, if you look at the homework, the 1.5 section has actually been open for you already. It's actually been open the first day. So that way, in case tomorrow we cover a good majority of it, if you like to work ahead, then you can go ahead and do so. Otherwise, typically the way the homeworks work is that the new homework assignments don't open up until Monday morning after the old ones have already been past due. But throughout the semester, if there's ever a case where you would like to work ahead, then all you'd have to do is send me an email message and I can go ahead and open assignments up for you earlier. If, for instance, you want to get a jump on the next week's homework, then by all means, please send me an email and I'll be happy to open that up early for you. But 1.5 is actually already open for you already. So when we do that section, we'll probably be able to do a lot of that tomorrow. So you'll be able to answer some of those questions ahead of time before next week, if you wish. All right, so we're going to go and jump into circles. Okay, so circles is, you probably haven't seen these type of graphs before. And so circles have a unique equation to them. And so actually the way circles work here is I'll just draw a quick sketch on that. You've got some picture that's up here. And so I'm going to label this as H and K. So HK would be the center of the circle. And then of course you have an R as well. So this can be drawn anywhere, any quadrant, but you have an HK for the center and you have a dotted line, the distance from the center to the outside of the circle, that's going to be considered your R. So this right here, this HK, that's the center of the circle. So this is the center. And then XY would be considered one other point on the graph itself. So the way that we're going to figure out the equation for a circle, I kind of show the steps here, but I'll just explain what's going on. We're taking the distance formula that we already learned about. We did that on the first day of class in 1.1. And then we're going to put in the HK and the X and the Y into each of those. So basically this would be my X2, Y2, and X1, Y1 would be there. If you take those variables and plug them into the formula here, we have X2 minus X, actually, I think I reversed those the way I set this formula up. I think I did X1, Y1, X2, Y2. Yeah, now that'll make more sense. Okay, so if I label these as X1, Y1, and X2, Y2 and plug them into the formula like we have here, X2 minus X1 would be the difference in the x's. So X2 is X minus the X1, which is H. And then I have Y2 minus Y1, so I have the Y minus the K that I have here. And then the distance that you're finding, if you're trying to find the distance from the center, HK, to a point outside there, which would be XY. So then that would end up being the radius is what you'd be finding. So instead of the D, we'll put an R for the radius. Then you just square both sides to get rid of the radical. And then this ends up being what's referred to as the standard form of a circle. Okay, so this is the actual equation of a circle. X minus H quantity squared plus Y minus K quantity squared equals R squared. HK is the center, and then we have R as the radius. So we're going to be working, this is the main formula the standard form here. It's the main formula we're going to be working through in this section here. So this example, write the standard form of a circle with a center of -2, 3, and a radius of 4. They also want you to graph it. So actually what I'm going to do is I'm going to graph this one first before I even do anything with the formula, because you actually don't even need the standard form in order to graph something. All you need is the coordinate for the center and then the radius. If you have those two pieces of information, that's enough for you to graph. So let's go ahead and graph this one just from the given information that we have here. The center is at -2, 3. So let's plot that one first. So starting from the center, we go to the left, and we're going to go up 3 and plot that right there. Now the radius is 4, which means that from the center, I can get a couple points that I can use as reference in order to graph this. What I'll do is I'm going to go up 4, make a dot, and I'm going to go down 4, make a dot. I'm going to go to the left 4 and to the right 4 units. So from the center here, I go up, down, left, and right with the radius. Then that's going to give me the 4 points that I can use in order to draw in the graph. So that's how you graph a circle. You plot the center, then you use the radius to go up, down, left, and right with that center to get these 4 points and that you can use to connect this together. When you do this in MyOpenMath, there'll be a circle tool that you'll select. You'll click on the center, and then as you move your mouse, the circle will get bigger and smaller as you do that. You can just move your cursor out to, doesn't matter, any one of these points, and they'll lock in your answer. So click on that, and then you just move the cursor out maybe to here, then release, and then you'll just click your answer there in that case. But we also want to write the standard form of a circle. Okay, so this is going to be your H and K. That's the center that was given. And the 4 is going to be the R. So what I do is I'm starting with my X minus H squared plus Y minus K squared equals R squared formula. And now I'm just going to plug in the information here. So I have X minus -2. And I have Y minus K is 3. That's quantity squared. And then I have 4 squared right there. I can simplify this. X plus 4 squared plus Y minus 3 squared equals 16. So this down here, that last line there, that's going to be the answer that you'll type in for the equation, the standard form equation of a circle. That would be this one right here. Now, it is okay if you want to leave your answer as 4 squared. That's fine. MyOpenMath will take that as an answer as well. So, but if you want to square it, make it 16, that's fine. You do want to simplify. If you've got double minuses, you do want to simplify that at least. But again, you can leave this as a 4 squared if you wish. Okay. All right. So next, we'll do another one of those. Okay, write the standard form of the circle, center 5, 1, and radius of 3 and graph. Okay, so here is the H, here's the K, H, K, and R. But let's go ahead and graph this first. We'll go to the center. Center is 5, 1. 1, 2, 3, 4, 5, and 1. The radius is 3, so we're going to go up, down, left, and right 3. So I go up 3, down 3, to the left 3, and to the right 3. We'll have something about right here. Kind of goes a little bit off the graph there, but this is what it'll look like. All the ones you'll do in MyOpenMath, you don't have to worry about the graph going off the grid that we have here. All the ones you do in the homework will fit inside there. But this one, we'll just go ahead and make the sketch, make it go outside a little bit here. And that right there would be the graph that you would have. So we went over 5, up 1, and then we did the radius of 3. Next, we want to come up with the standard form equation. So again, you're always using X minus H squared plus Y minus K squared equals R squared. And then we're going to plug in this that we already labeled, X minus H, which is 5, Y minus K, the K is 1. And then I can either write this as 3 squared, or if you don't want to write 3 squared like that, you can also just write it as a 9. Either one of those would be acceptable. Again, MyOpenMath would take either one of those for the answer on that. Okay, so we have that one. And that's all you have to do on this. So these are ones where they gave you the center and the radius and you made the equation. And now the other problems that we're going to take a look at in this section are ones where you want to find the center and the radius from the equation itself, and then use that information to graph. So this time, we actually have to work with the equation first because we don't have enough information now to graph this. We got to find the center and the radius first. Okay, so the way that we're going to do this one is, remember the formula that we have for this is one where we have a minus sign always. That's in this one. So we want to make this equation look like this one right here. So what I'm going to do is I'm going to change the +1 there. I'm going to write that as x minus a -1. Okay, so I'm just changing the +1 into something that has a minus, so that way it matches the minus sign that I have from the formula itself. The next I have y -3. That's okay. I'll just leave that as is. And then the 25, I want to write that as something squared. So 25 can be written as 5 squared. So I've basically taken the original formula and I'm rewriting it like this. So now that's going to tell me that the center is going to be whatever comes after the minus sign, -1. And then this is going to be whatever comes after the minus sign will be a 3, so -1, 3. And the radius is going to be 5. Now a shortcut for doing this, instead of doing this step here where I'm writing it all out in the formula, all I need to do is actually just simply take the opposite sign of the numbers that you see inside the parentheses. For instance, instead of doing all this step right here, I can skip all that. If I see +1, then it becomes a -1 here for the center. If I see a -3, it becomes +3. So that's an easier way to do it. Just simply take the opposite sign of the numbers inside. Mathematically, I do have to show you, of course, where the math comes from, since, well, I'm a math teacher, so I do need to show you where the math comes from. So that would be basically this step right here. But again, the shortcut, you don't have to show this step, this work right here. You can just take the opposite sign of both of these inside the formula to get the answer there. Okay, so now I have the center. Now the last thing I want to do is to graph it. So I do -1, 3. Okay, so I plot the center first. I'm going to go up with 5, down with 5, to the left 5, and to the right of 5. Like that. Now I have my 4 reference points that I can use to draw the graph right here. And so that's going to be my final answer. I found the center and the radius that indicated that, and then I drew the graph to go with it. We'll do another one of that same type where we want to find the center and the radius. Let's do that one next over here. All right, so this right here, we're going to first rewrite it as x -3 squared. Now the y squared there, you can write that as y -0 squared. Okay, so because there's nothing afterwards, then you're allowed to do that. So y -0 squared we have there. So the question is, how do we handle this one over here? So this one, I'm just going to go ahead and show you the trick for doing that. You're actually going to write it like this. You're going to take the square root of 13 and then square it. Okay, so square root of 13 doesn't go into anything, but if you take the square root of 13 and you square it, you're going to get the same thing you started with here. And we're doing that because that way we can write the center and the radius. The center is going to be opposite sign of this, which is 3, and opposite sign of that, which is going to be 0. So center is 3, 0. Now the radius is actually the thing that's being squared like that. So last time we had 5 squared, but this time we have square root of 13. And so that's going to be your radius. Now, if you want to put square root of, you can do square root of 13 on your calculator, and that would be better because that way we'll know about where to graph that. So that's what we're going to do here. We're going to go ahead and take the square root of 13 and write it as a decimal, which is about 3.6. So this is approximately 3.6. Okay. So to graph this one, we're going to go 3, 0. So 3 to the right, we don't go up and down any because we have a 0 there. And we're going to go up, down, left, and right about 3.6. So I'm going to go up 3.6, make a dot here, go to the left 3.6, about right there, down 3.6, And then to the left, 3.6 will be just a little bit past the 3 there, so about right there. And then graph it, it's going to look something like this. Now, they're not going to have you graph something using the graphing tool in MyOpenMath with the square root for the radius, okay, because it only works as far as whole numbers, that graphing tool that's in there, so you won't see that type in the homework. But again, if you see something like that, now you know kind of how to deal with that and get the center and the radius. All right. Okay, now the next type of problems that we're going to come to here would be ones like this, where if you look at the format here, this doesn't look anything like the forms that we've talked about so far. So in fact, what we need to do in order to be able to find the center of the radius and then graph this one, what we have to do is we need to put this into the standard form and go about doing that. So we need to make it look like this previous one, something like that, where you have the parentheses, quantity squared, you know, for each of those. So we need to make that happen down here. Now, the way that we're going to do that is we're going to use a process called complete the square method. We're going to use for this. So I'm going to walk you through step by step how to do that, since it may have been a while since you've done complete the square. So let's do that first. We're going to rearrange all this. So I'm going to put the x's and the y's together. So I'm going to put x squared plus 10x, put those together. Now I'm going to leave a space here because eventually we're going to be doing a complete the square step, and we're going to have a number that's going to get added in this space. So I'm just going to leave that space open. Then I have the y's, y squared minus 8y. Again, I'm going to leave a space there. The 16, I'm going to move that over to the other side of the equation there. So we're going to move that over, and so now we have these spaces complete. We're ready to do the complete the square steps. Now, to complete the square, what you're going to do is you're going to take the number in front of the non-squared variable, you're going to divide that by 2, and then you're going to square it. So I'm going to write the steps down over here. Step number 1, we're going to take the 10, we're going to divide that by 2, and we get a 5. And then for step number 2, we're going to take -8, divide by 2, and we're going to get -4. The number that you get in step number 4, we're going to add that to both sides of the equation. Okay, I'm sorry, what am I doing? Never mind here. Sorry about that. I'm doing 2 things at once here. Sorry about that. Step 1, you take 10 divided by 2 is 5, and then 5, you have to square it to get 25. So 25 is what you'll add to both sides. I'll do that in a second here. Let's do the complete the square steps for the -8 here. Okay, so -8 divided by 2, we get -4, and we have -4 squared, and you get 16. So I did this is the complete the square steps I did for the x and then also for the y. Okay, pardon my dog barking in the background. She's Maltese, so she barks at almost everything that she hears. So I apologize for that. Okay, so 10 divided by 2 is 5, and then 5 squared was 25. Now this 25, I'm going to add that here. I'm going to add it right here. I got to add it to both sides of the equation. Then for step number 1, for the -8 rather, step 1 was -8 divided by 2 is -4, and then I have -4 squared, and that's going to be 16. So I'm going to add 16 here, and I'm going to add 16 over here. Now the reason why it's important to add it to both sides is because if I just add 25 and 16 here without adding it on this side, the equation is not balanced, and I've actually changed the original problem from what it is. So this is very important to remember to add that number to both sides. It's the most important step, and that's usually where most people make the mistake, is forgetting to add that to both sides. So step 2 is always the number you're adding to both sides of the equation. Add 25 here, add 25 here. We got 16 down here for that second step, add 16 and add 16. Now the reason why we want to do that is because by completing the square, it's automatically going to turn the x and the y's into something that looks like this here. You have x quantity squared and a y quantity squared. And then on this side, you're going to add that together. The 16s cancel out, and we get a 25 on the right-hand side. Now the number that goes inside the parentheses is going to be the step number 1 that you got by doing complete the square step. So step number 1 here, I got a positive 5, so I put plus 5 here. Now step 1 for the y's is -4, so I'll put -4 in for that one. So now I'm finished. I have used complete the square to get the standard form here. Now that I have the standard form, I can now indicate the center and the radius. The center is going to be opposite sign of what you see here. Opposite sign of plus 5 is going to be -5. Opposite sign of -4 is +4. So I get -5 and 4. Now the radius is always the square root of the number that you see after the equal sign. Square root of 25 is 5. So again, that's how you do that, by using the shortcut without going through those algebra steps that I did earlier. So we have center and we have radius. Now we have center and radius, we can now graph that. -5, 1, 2, 3, 4, 5, and then we're going to go up 4, 1, 2, 3, 4. And the radius is 5. So I'm going to go left, right, up, and down 5. This is going to go off of the graph here, but get the basic idea of what it'll look like. It'll be something like this, is what that'll look like when it's complete. Okay, so we got up 5, down 5, left 5, and right 5. We go from the center, and that's going to be what your graph looks like. Again, the ones that you do in My Open Math, they will all fit inside the grid that you have here, so you don't have to worry about that. That would be your answer on that one. So we are going to do another one of these, at least where we do the complete the square method. So we'll do that another time. So let's try this next one. Okay, so we have another one that's here. Okay, now this one, we're going to, first of all, notice that there's numbers that are in front of the X and the Y. Before you do complete the square steps, you want to make sure there's a 1 in front of the X and in front of the Y. So let me write out the equation first here. And my first step I'm going to do is divide everything by 2 so that I can get x squared and y squared by itself. So that's the first thing you must do all the time, is to do that. Okay, so we got that as the first step. The next thing I want to do is rearrange and put that together. So I'm going to do x squared plus 4x. I'm going to leave a space for the complete the square step. Now I have y squared, but notice I don't have a single y afterwards. That means I'm not actually going to be completing the square on the y this time. I'm only going to complete that on the x value. The x is only, not the y. So I'm going to just leave that as y squared, and then I want to take the -7/2 over to the other side, just like this. So a question that comes up here before I continue, I want to talk about the dividing by 2 step. So a question that's usually asked is, well, what if one number is a 2 and one number is a 3? Then which one do I divide by? So the answer to that is actually, you're not going to see that question come up at all in the homework. Now, the reason why that is because if I had like a 2 here and a 3 here, in fact, I would not have a circle. I would end up having an ellipse. And ellipses are something you're not going to graph until you get to Math 127 with trig. That's when they cover those kind of graphs over there. So in this section, we're only dealing with circles. So they can't give you 2 different numbers here, because again, if they did, it would not actually be a circle. So they have to give you the same number in front. That's why usually they give you one like this, where there's other numbers in front of the x squared and the y squared. You'll just divide by the common number that's in front of both of those. So again, we had to do that step to take it down to a positive x squared like that. And so that way we can continue and do the complete the square step. So now we're going to complete the square with the x. So here's our step 1 and step 2. Step 1 is you always take the number in front of the non-squared variable and divide it by 2. Step 2 is you always square the number that you got in step number 1. Okay, so that's 2 squared equals 4. The number you get in step 2 is what you're going to add to both sides of the equation. So I'm going to add a 4 there and add a 4 there. By doing this, that's going to automatically put this into a x quantity squared on that. So x squared plus 4x plus 4 would be a perfect square that would go into this shape like that. The number that goes inside the parentheses is the step number 1 answer that you got. So because it's positive, I will go ahead and put a +2 right there. Now for the y, that you can just write this as y minus 0 squared. You can even do y plus 0 squared. It actually doesn't matter. Y plus 0 or y minus 0 would just be y squared. So you can do either one of those. It's fine. Next, we have a 4, and then I have, so this part here, I want to combine that together. So that way I can get the center and figure out what the radius is. So -7/4, you can write this as 8, -7/2, the same thing as 8/2. So if I have -7/2 plus 8/2, I'm going to get 1/2 the answer, or you can just do that in your calculator to combine that together. Okay. Now the center here is the opposite sign that I see inside the parentheses. So -2 and 0 that I have for that one. Now for the radius, it's always the square root of the number I have after the equal sign. So square root of 1/2 is what I have there. And you can write that answer in my open math. That's okay. That answer would be acceptable. You could also, if you wanted to, you could do square root of 1 over square root of 2, which equals 1 over √2. And then you can rationalize that by multiplying top and bottom by the radical, and you get √2 over 2. So either one of these would be fine, either square root of 1/2 or square root of 2 over 2. It doesn't really matter. Either way, if you do that in a calculator, it's about 0.7. So when we graph this one, we're going to go -2, 0, which is right here. The radius is 0.7, so it's going to be a real tiny circle this time, something that's going to be less than 1, so we get that. So it's a real tiny circle we have. The answer on that one, but that's what the graph would look like on this particular one. Now, what I want to do here is we're going to do this last problem, and then if there's time, I'm actually going to do one more of these center and radius problems for you. I'll pull one out of the homework to do. But before we do that, let's go ahead and jump into this one. Now, this one is actually going to combine a couple sections together as far as what we've done so far, circles, and also working with the distance formula that we did back in 1.1. So we're going to actually take a look at both of those here. All right, so it says the endpoints of the diameter of a circle are these here. Determine the coordinates for the center of the circle and find the length of the radius, then write the standard form. So first thing we're going to do here is actually we're just going to go ahead and plot the 2 points that are given, because we have to get an idea of what this problem is actually asking. So I'm just going to do a quick sketch over here of a graph here. So I have 2, 6 is right there. -4, -2 would be here. And so I have these two connected. These form a diagonal, which means, or diameter, I should say, which means that the circle itself is going to look something like this. Okay, so we basically have a circle that's drawn. We've got these 2 points that are on the circle itself. They're the endpoints of the diameter. Okay, so it means the center of the circle would be kind of right in the middle, somewhere around here would be where the center actually is with that. So that's the type of problem. So what it wants us to find out is the center of the circle and then the radius. Okay, if I want to find the center of the circle is actually going to be on the midpoint of the diameter. So again, let me write that out. Center is at midpoint of diameter. Okay, so that's the basic idea. That's why we had to draw the picture first to get an idea of what's going on. That's going to tell us that somewhere the midpoint of this is going to be the diameter. So what I'm going to do is I'm going to use the midpoint formula. Okay, so we're going to recall that one from the previous section. I'll rewrite that. Okay, so this is the midpoint formula, x1 plus x2 over 2 and y1 plus y2 over 2. That's the midpoint formula. And this is actually going to tell us what our center is. Now the points we're putting in, we're going to use these. So I have x1, y1, x2, y2. Let's put those into here. Okay, so I have 2 plus -4 over 2. And then I have the average of the y's. I have 6 plus -2 over 2. If I simplify that, -4 plus 2 that's -2 over 2, which is -1. 6 minus 2 is 4 over 2 is 2. So my midpoint, and also this is going to be the center, is -1, 2. -1, 2 is about right here. That would make sense. So that point right there is on the midpoint of the diameter. And so there it is. That's our center. Okay. Now, next thing it wants us to find is the radius. Now, the radius is going to be the length from the center to either this point or that point. The radius is exactly the same. So the radius is basically it's half of the diameter. Okay, so what I'm going to do is I'm going to use the center, which is -1, 2, and I'm going to pick either this point or that point. It doesn't matter. I'll just pick the 2, 6 since it's easier. It's all positives there. And what I'm going to do is I'm actually going to use the distance formula now, and that's going to tell me the distance from the center to this point right here, 2, 6. So I'll just do x2, y2, x1, y1, and I'm going to put that into my distance formula, which is actually going to be the same as the radius here. So it's going to be the difference in the x's. Okay, so let me write out the formula. x2 minus x1 squared, and then y1 minus y2 minus y1, quantity squared there. Okay, so that's my, it's distance equals, but in this case, I'm actually going to find the radius. Okay, so radius is equal to the square root of x2 minus x1. So I have -1 minus 2, quantity squared. And then I have y2 minus y1, 2 minus 6 squared. So that's going to be square root there. I have -3 quantity squared. And I have -4 quantity squared here. So if I work that out, I get 9, +9, and +16. I get square root of 25, which is equal to 5. So 5 is going to be the radius. So now I found the center and I found the radius of that circle. So I found both of those. Now the last thing it's asking for is it says write the standard form of a circle. All right, so standard form of a circle would just be, I need to put it back into the x minus h quantity squared, y minus k squared equals r squared. So I'm using just putting all that information back in. So the standard form equation, I'm going to do x minus h. This is h and this is k. If I do x minus the -1, I'm going to get +1. I have y minus k, y minus 2 squared, and then I have 5 squared I'll put here, or 25. Okay, so that would be the exact equation of this circle that I just drew here. this would be the exact equation for it. So again, all I did was I just plugged it back into the original formula that we had, x minus h squared and y minus k squared. So I had that one listed. Okay. All right, so now that I have that complete, what I want to do is I want to take some time to do one more problem, and I'm going to go ahead and pick since we have a couple extra minutes, I'm going to pick a problem from the homework where we have to find the equation, the center and the radius for one where you have to complete the square. So I'm going to go ahead and do this one. So I'm going to go ahead and share this question now for you. Okay, so let's take a look at this problem. Okay, so this is a problem from the homework that we're going to do. So I'll give you a second to take a look at that, and then you can also write that down too, because it's going to be a little bit, because I'm going to be moving away to a blank screen to show you how to do that one. So go ahead and you want to write that down now, and then we'll go ahead and we'll go over this in a second. All right, so now I'm going to go ahead and switch over to a blank screen. Now that you guys have had a chance to see that, we will jump to our blank screen that we have here. So let me switch this back over now that we've seen that. All right, so okay, so we're going to go to a blank screen that we have here. All right, so I've got the original problem. I'm just going to write it down for you so you can see it. So we don't have to keep jumping back and forth the screens here. So here's the original one that they gave us. We want to find the center and the radius and graph this one. So I did want to show one more example just so we know how to do this with the complete the square. How you would do this is you want to rearrange put the x's and the y's together. And notice that we're leaving some spaces in here for the complete the square. So I've got a space here. I put the x's together. I left the space open for that. I put the y's together, left the space open for that. The 9, I move that over to the other side of the equation. That's always going to be your first step when you do that. Now, next thing we're going to do is we're going to do the complete the square step. Step 1 and step 2 we'll do for the x's. Step 1 and step 2 we will do for the y. The number in front of the x here is -8. So I'm going to divide that by 2. And that's going to give us -4. Then in step number 2, you're going to take that number and you're going to square it. And that's going to give us 16. The 16 we're going to add to both sides of the equation just like that. Next, we're going to take the -6. So -6 divided by 2, you get -3. -3 squared, we get 9. I'm going to add 9 to both sides of the equation. Again, that's really important to remember to add this number to both sides of the equation. Okay, and so that way the equation is balanced. When I do that, that's going to turn this into an x quantity squared and a y quantity squared, just like that. This, if I add the 9s will cancel out, and I'll just get a 16 on the end there for that one. The number that goes inside each of the blanks is going to be step number 1 of your complete the square step. So we're going to do -4, because that's a minus here. And we're going to do a +9, because this is a +9 right there. So now I've changed the original problem into the standard form, and I can now indicate the center and the radius. Okay, so center is opposite sign of both of these. Okay, so that's going to be the, oh, you know what? I put the wrong number inside the parentheses here. Just notice that this is -3, so I put the wrong number. It's always step number 1 of your complete square goes in there. So That's a -3. So -4 goes in here, and a -3 goes in there. You're always using the step number 1 number to go into each of these parentheses just like that. So now we have it, correct? So center is going to be +4 and +3, it's opposite sign of both of those. And the radius is equal to the square root of 16, which is going to be 4. So I have both of those. Okay. And then we'll go to the graph. The graph part, let's do that together on, that's another reason why I wanted to show you this in my open math. So let's go back to the my open math problem that we have now that we've worked all this out. The center here, we already said was 4, 3. And you want to make sure you have those parentheses there on that 4, 3. The radius is going to be 4. And then we're going to use the graphing tool. So you want to hit the circle tool here on that. And we want to click on the 4, 3. So 4, 3, that right there is the center. And as you move your cursor, we see that this is going out like that. So I want the radius is 4, which means I want to go to this point right here. So from the center, I clicked on that and I went 1, 2, 3, 4 over and clicked on that. And it's going to create the graph for us. Let's see if we're all correct. And we are. And so that would be your answer. That's how you would do that whole problem in my open math by using all that. So I'll go back to the notes again, just in case you didn't get all that from before. I'll go back to the notes page so you can see that one. And that was the problem that we had. So I think from that, we're just going to go ahead and stop it. So now actually we finished all we finished all the notes basically that you need for the homework for this week. Now we are going to have lecture tomorrow, and we're going to be moving on to 1.5. And it doesn't matter whether we finish 1.5 or not. 1.5 is actually not going to be due until next Sunday. So this week you only have sessions 1.1 through 1.4 to do. But then tomorrow we'll start 1.5, and then even if we finish it, it doesn't matter. Like I said, that won't be due until next Sunday, but I will have that section open for you earlier in case you'd like to work ahead. So at this point now is the time for some questions. So if you don't have any questions, you can feel free to leave the meeting now. But if you do have some questions, feel free to ask on chat or over the microphone on that. So it says on the last extra problem, can you explain how you got the 4 for the radius? Yes, that's just the square root of the number that you have after the equal sign here. Remember that the way this formula works is that I have h here, and this is k here, and then this 16 is always considered to be r squared. So in a way, what you're thinking of that is the r squared on the end. Since this is r squared, you have r squared is equal to 16. So what I have to do is I need to take the square root of both sides in order to figure out what the r actually is. So that's how we get the 4 on that. But the shortcut way would just be to simply take the square root of that number you have afterwards. But this is mathematically why we're doing that, because the original equation has h's, k's, and r squareds. Then this last number should be equal to r squared. So you'll take the square root of both sides and get the answer that way. So that's how we get the 4. Okay. Other questions you guys have? All right, looks like there's no other questions, so I'll go ahead and end the meeting. Enjoy the rest of your day. I'll see you guys tomorrow.